Hello students, today we are going to discuss equipotential surface and its properties. As the name suggests, equipotential surface, it means the potential is same everywhere in a surface. Let us see the proper meaning of equipotential surface and we will discuss its properties also. Now, as we discuss the definition, any surface which has same electrostatic potential at every point is called an equipotential surface, right? It means, suppose you consider a surface here, you can see the surface here. Any point you take, say point A, another point B, the potential whatever is there at point A is exactly equal to the potential at the point B. If you take any other point in the surface, everywhere, each and every point will have the same potential. That's why the surface is known as equipotential surface. Now, we will see some of the properties of equipotential surface. First property is, no work is done in moving a test charge over an equipotential surface. It is not only test charge, any charge, you want to move it from one point to another in an equipotential surface, no work is done. See, suppose we choose a unit positive charge and we want to move it from point A to point B. So, the work done to move a unit positive charge from A to B will mean it is the potential difference between B and A, and the potential difference B and A will be given by VB minus VA, which is equal to WAB upon Q0, as we have derived earlier. It means since the potential of point A and B are same, so VB minus VA will be 0. It means WAB by Q0 will be 0. It means that WAB is 0. WAB actually is the work done to move Q0 charge from point A to B. So whatever charge we can choose, the work done will always be 0. Here in this example, we have chosen Q0 charge. To move it from one point A to another point B, the work done is 0. So we always say that whenever we move a charge from one point to another in an equipotential surface, the work done is 0. Okay. Now, next point. The electric field is always at right angles to the equipotential surface. Now, do you remember a formula in which we have discussed that potential difference between 2 points B and A, that is VB minus VA, is given by the line integral of electric field? Now, if we consider that line integral of electric field, that means to move unit positive charge by a very small distance, the work done will be E dot dl. To move Q0 charge, it will be Q0 into E dot dl. This expression we have derived earlier when the relation for potential difference was considered. Now here you can see E dot dl is the amount of work done to move a unit positive charge. For Q0 charge, so Q0 into E dot dl, we have already calculated the work done to be 0. So the work done is 0 here. It is 0, it means that E dot dl, which is E dl cos theta. So the value of cos theta is 0. You can see here Q0 comes here, so 0 upon Q0 is 0 only. So E dot dl is 0, so cos theta is 0. If cos theta is 0, it means that theta is equal to 90 degree. Theta is the angle between electric field and the length along the surface. That means the surface and the electric field, they makes an angle of 90 degrees. So you need to understand that always the electric field cuts the equipotential surface at an angle of 90 degree. I hope this point is also clear. Now the next point. The equipotential surface helps to distinguish region of strong electric from those of weak electric field. You need to understand this. Equipotential surface, by studying the equipotential surface, we can guess where the electric field is more and where it is less. Look at a charged particle. Suppose a positive charge Q is there. Now look at the position of the electric field. These are the electric lines of force and the equipotential surfaces. It will be naturally spherical in shape because every point in the sphere is equidistant from this charge. So the potential will be same along this sphere. Now you can draw as many as spheres, all having the same center where the charge is present. All of them will have same potential but different from the others. So all of them will be the equipotential surface. Now you need to understand one thing. Electric field, we have derived a relation. It is equal to the negative gradient of potential. It means that dr here can be written as minus dV by E. So dr is inversely proportional to E. Dr is the distance between two equipotential surfaces. Now see, these spherical surfaces 1, 2 and 3 we have shown here. These spherical surfaces are equipotential surface due to the charge plus Q which is present at the center. Now look at the distance between them, which is given by dr. The distance is not same. Here the distance is less, but as we move away from the charge, the distance increases. That is, dr increases. Now we know that the electric field in this direction decreases, but dr increases, which is shown by the equation here. Here you can see dr is inversely proportional to E. It means that where dr is more, electric field will be less. I hope this is also clear to you. Now the next point is the electric potential tells the direction of electric field. We consider the formula here, E is equal to minus dV by dr. Now the negative sign here shows that the direction of electric field will be such that in that direction the potential decreases. So the direction of electric field is a direction in which the potential decreases. This is the significance of the negative sign. As we all know, as we move away from the charge, the electric field decreases. So the electric field decreases, and that will be the direction of electric field where the potential also decreases, right? We now move to the next point. No two equipotential surfaces can intersect each other. As we all know, like suppose you consider two equipotential surfaces and consider that they are intersecting each other. Suppose one has a potential of VA and another equipotential surface has a potential of VB. Now where they intersect, at the point of intersection, there will be naturally two potentials, one for the first surface which is VA, another for the second equipotential surface which is VB, and that is not possible. So at the same point we cannot have two potentials. So that means the equipotential surface will never intersect each other. I hope that the topic, whatever is discussed here is exactly clear to you. If you need to clear any doubt, then you can post the doubt also. Thank you.